doesn't look like a curve, it looks like a box. And the area of a rectangle, of course, the area in here is 1.0000. Area equals base times what? Height. And the bottom is usually minutes or hours, depending on the question. And the height is pretty much the probability. Now, we're going to do one here in a minute, so it's not a big deal. Actually, out of all three, the time is the easiest ones to do. You're talking about 2 questions on a test. So if we take the Unit 3 test tomorrow, you'll probably have 2 questions regarding time. And they're the same. They're the same. They're not different from each other. They're the same 2 questions pretty much. Okay, the next type of problem is area under the curve where mu is equal to 0 and the standard deviation is equal to 1. Y'all remember me telling y'all? Hold on a second. Hold on 1 second. Go ahead and write that down. Y'all remember me telling y'all to make sure that you printed out your bell curves? Well, this is where you're going to use them in 7.2. But the difference between the two is that one is dead. This one has a mean of 0 and a standard deviation of 1. And this one has a mean of any number besides 0, maybe 100, and a standard deviation of 10. So that will be 100, 110, 120, 130, 90, 80, 70. Okay, now the main reason for this page right here is I want you to see that there's 3 different type problems. Does everybody see that? Hopefully you do.
Yes.
Now, the only other thing I want to tell you about is the z-score formula is equal to x minus mu over standard deviation. And the x formula, which is equal to Oz plus mu. Are those 2 very important formulas? Yes. So I want you to take your handy-dandy highlighter, and I want you to highlight these 2 because you're going to use them in 7.1, 7.2. What else are you going to use? Well, in 7.1 and 7.2, you're also going to use your calculator. Second, VARs. And in 7.1 and 7.2, we're going to be using 3 of the applications with the second VARs. One is called normal CDF. Normal PDF and inverse norm. Normal CDF is the most used, and it's going to be used whenever you're finding a range. Area with a range. PDF is precise or exact. That's not right. There we go. And inverse norm finds the z-score when given an area. Now, we'll get to that later. I'm just trying to, again, give you a kind of an overview of what Chapter 7 looks like, because we're only talking 2 sections. So, and it covers these 3 things right here. So I'm going to leave that on the board there for a couple of seconds so everybody can write it down, and then we're going to go ahead and start working on a couple of problems.
Quick question.
Yes.
So when you say range goes with like the normal CDF, are you referring to like the word problems?
A range, no, range like from 0 to 3, or
okay.
from 110 to 130. We're finding the area under the curve. So here I said from, let's say, -1 to +2. We're finding that area right there. And then over here, we could go from 70 to 90. What's that area right there? That's what we're finding. We're finding the area under the curve, which is something that you know, so a lot of people don't, you know, this is not something that you do every day, finding the area under the curve. Now, we did it with the empirical rule, and we're going to use the empirical rule as an estimate. So don't forget the empirical rule. We're going to use that for these 2. So, in fact, I'll take my green, and I'm going to put empirical rule here and here, because you're going to use the empirical rule for an estimate in 7.2 and 7.2. But I'm going to incorporate that into the problem as we do it. So I need to make sure everybody's got this page written down. Does anybody need more time? Miss Dennis, I know you came in late.
I'm good. I got it.
You got it? Okay. Yep. So now I'm going to go to the handy dandy homework, and I'm just going to pull out some questions in 7.1 that I would pick for your test. Okay. There we go. Homework 7.1. And let me see if I can find one.
I have a question about the homework.
No, I'm not answering questions. What?
It's set to 3 attempts per question. Is that staying like that?
I'm sorry, it says what now? I didn't understand a word you said.
It's staying as 3 attempts per question.
Oh, God. These teachers. Whoever's in charge of 120 has set that. Which section is it doing that on?
I think it's doing it on all of the later ones. I think
It does
6
it on all
and
of them.
7 are like
6.1 and 7?
Yes.
Yeah, it does it for all of them.
That's so irritating. I'll fix it. Just remind me to fix it at the end of the class if you don't mind. Before some of these teachers. I'm sorry. Some of these teachers are just stupid. Okay, Miss Garcia, when you're doing your homework out of your book at home, when you try it 3 times, I'm gonna come to your house and I'm gonna slam your book closed and say you can't work on any more homework.
Thank you. I'll go live in a dumpster afterwards.
That is so. I'm sorry, it's stupid. Some of these teachers, they need to get another job. I'm sorry. All right, here's your question.
There's a couple girls here that I think their friends with that they all look like.
What was that?
She's with them, yeah.
Was that your background, Miss Dennis?
Sorry.
Okay, that's fine. You can leave it. That's fine. I just want to make sure nobody was asking a question. All right, write down this problem. The graph to the right is the uniform density function, uniform whatever, for a friend who is X minutes late. Find the probability that the friend is at least 8 minutes late. Okay, there it is. Okay, I'm trying to get it where you can see it. I want you to draw that graph. Just draw it. That's as big as I can get it. I'm sorry. Let me see if I can do this. No, it won't enlarge. Okay, that's all I'm gonna be able to do. I'm gonna draw it on the board, and then we'll go to the board after everybody gets through drawing it. Zero to 30. 10, 20. So in the middle. So that's going to be 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. Now, I'm going to show you, and the question says the probability that the friend is at least 8 minutes late. All right, so here's our problem. Now, first of all, we know it's uniform distribution because it is time related, so we can't control it. So that's why it's a straight line, because time goes forward for Miss Garcia, and it doesn't change for Miss Garcia, and it doesn't change for Mr. Michelle. It goes, and it doesn't care whether you're with it or not. Thus, death. Okay? It doesn't matter whether we want to die or not, does it? It happens because time cannot be controlled. All right? It can't be sped up. Well, there are some people you graduate high school with that look like they're like 50 years older than you are, but that's because of, their choices. But anyway, it doesn't speed up and it doesn't slow down. And when it's your time, it's your time. There's nothing you can do about it. All right? Now, I'm not going to get into health and stuff like that. What I'm saying is, when it's your time to die, nothing's going to stop that. Y'all ever seen the movie about trying to delay death? What's it called? The horror movies. There's a bunch of them.
Final Destination?
Yeah. You ever seen those movies? They're very true, because if it's your time, it's your time. Anyway, to make a long story short, I got to find, what do we have? Somebody tell me, what do we have with this rectangle?
The area.
We've got the area. So I'm going to highlight the area green because we've got the area. So I'm going to take my green highlighter, and we've got the area. What else do we have?
The base.
We've got the base, which is on the bottom. We've got the base. Sometimes, now in this problem, you are given the height, but sometimes you don't have the height. So how do you get the height? I'm showing you, what if you don't have the height? Well, this is how you get the height. The area of a rectangle or quadrilateral is equal to base times height. So therefore, 1.0000 is equal to 30 times h. And how do I get rid of multiplying by 30?
Divide by 30 to both
And if
sides.
I do it on one side, I got to what? Do it on the other. So my height is equal to 1 over 30, and that is my height. Now, in this problem, it was given, but I wanted to show you how to find your height. Because in some questions, they will not give you the height. And now for the actual question. Somebody tell me what at least 8 minutes means. That means the lowest number has to be what?
8 minutes.
8.
Lowest number is equal to 8. So I'm going to go in here, and there's 5, 7 is right here. So 8 minutes is right there. Now I'm going to draw a line at 8 minutes. And you are asked to find the probability at 8 minutes or more. Somebody tell me on a number line, what is more, to the right or to the left?
To the right.
To the right.
So you're going to find the area in orange. Area is equal to probability. I need you to write that down. Area under curve is equal to probability. Area under the curve is equal to the probability. So I'm going to go over here and I'm going to take my orange pen and I'm going to do this problem. Area of 8 or more, t is greater than or equal to 8, is equal to base. What's 30 divided by 30 minus 8?
22.
So the base is 22 times 1 over 30. And the area of t greater than or equal to 8 minutes is equal to 11 over 15. And I have no idea what that is, so I'm going to take my handy dandy calculator. 11 divided by 15. 0.7333. Oops. 0.7333 dot dot dot. Meaning it's repeating. Now, what does that mean? This right here is your answer. That means I've got a 0.73 probability of 8 minutes or more. My area is 0.7333. That's equal to my area. Or I've got a 73% chance that this guy is going to be 8 minutes late, at least 8 minutes late.
Is area under curve the one point, all those zeros?
That's the whole thing. Because what is the probability? What does probability go to in this whole book? What does probability equal? From 0 to what? From 0 to what? Miss Dennis, come on now. What does all your probabilities have to equal when you add them up?
1.
1, there you go.
But
Now, when I said that probability and area and percent were the same thing, this is what I mean. You could say in the classroom, there's a 73% chance that this guy will be at least 8 minutes late. There is a 0.73 probability that this guy will be 8 minutes or more late. Or the area under the curve at 8 minutes or more is 0.7333. That's what you need to know about that all three of these things are equal. All right, now I'm going to put another homework problem on the board, and I want you to do it.
Wait. Area, what's that? T is greater than 8.
Greater than 8. That's what the question asks. Yes.
Time is greater than less than 8. And where did you get 22 from?
The base.
Somebody was in here, that's why.
The base right here.
Okay.
Which is 30 minus 8.
Oh, okay. So to get the base, you do 30.
30 minus 8.
Okay.
Any other questions on this one? All right, so let's type in our answer and let's see what we get. Round to 3 decimal places, 0.7333 or 73. Yay! All right. Well, I hope okay, they're not going to give you another one, so I'll just give you this one. All right, y'all do this one. Do that one. Same
Homework
type
question 5 is similar to it.
Okay, number 5. Okay, try that one. I can't make it bigger. I'm sorry. That's as big as I can make it. I'm trying to get both the question. There's, let's see. Okay, there's the question. All right. It says the graph to the right is uniform probability. So that means the area in the box is equal to 1. So I'm going to draw a big drawing for y'all. The bottom is from 0 to 30, just like the previous problem. So 10, 20, and then 5 goes in the middle. 5, 10, 15, 20, 25. And then the height is equal to 1 over 30, so we don't have to do that. And they want to know, find the probability that the friend is between, so part A, find the probability that the friend will be between 25 and 30 minutes late. B says there is a 30% probability the friend will arrive within how many minutes? 30% probability. So that's 0.3000. Okay, so I'm going to show you what I got here. That's what I wrote down. Right there. That's what you should write down in your notes when you do this homework problem. And remember, area of a quadrilateral is equal to base times what? Height. Now, you don't need that for this A, but you might need that for B, because 0.3000 is equal to what? Area. So you're going to have to plug that into the formula. Okay, where is 25 and 30? Well, 25 is right here. So I'm going to take my handy dandy orange marker, and I'm going to put an orange line right here.
Hubert, before you go any further, would you mind explaining real quick how you got the 0.3000?
Yeah. What does the question say? It says B. What does it say? It is 10 o'clock. I'm not worried about that. You worry about that at the end. But what if there is a what?
Oh, 30% chance. Okay,
30%.
Sorry,
That's where the 0.3000. Remember I told you, percentage, probability and area are all very similar. Okay, so I want this area right here. So somebody tell me the area of the orange box is equal to, somebody give me the base. What's the base?
Would that be 5?
5. And what's the height?
1/30.
And you do the math.
Where you get the 5 from?
Come on now, man. Come on. Look at the base of the orange. Look at the
Oh,
base.
5 space. Okay.
There you go, Miss Dennis. All right. Area of 5/30, which is equal to 1/6, which is equal to 0.67. Okay, so that's the answer. There's a 66% chance that the person is going to be between 25 and 30 minutes late. I'm sorry, 0.16. 0.1666666. There's a 16% chance. Whew. How did I know I was wrong? Well, 50% would be right here. And that's not more than 50%. So I knew I forgot something. It's 16%, not 66%. Now, how do we do this part? Well, what are we given? We're given the what?
The area.
So I got to plug that in for A. So I'm going to plug 0.3000 is equal to base times what? 1/30. Well, Hubert, how do you know you're looking for the base? Well, look at the question. What does it ask for? Somebody look at the question. Tell me what the question asks for.
How many minutes?
What is minutes, X or Y?
X.
X. So that's the base. You're trying to find the base. So here we go. How do you get rid of multiplying by 1/30?
Divide.
Divide by 1/30. And if you do it on one side, you got to what?
Do it on the other.
Now, you can punch this in the calculator however you want to. I'm not going to make you do it any certain way. So B is equal to, somebody take 0.3000 and divide it by parentheses, 1 divided by 30, close parentheses. Somebody tell me what you get.
9.
9 minutes. So that means if everybody's going to meet at 10 o'clock, what time is Butthead going to get there?
10:09.
10:09. So it says round to 3 decimal places, so that's going to be 0.167. And 9 minutes. And you feel good about yourself. Now, those are 2 questions, and I got 7 minutes to show y'all 3 things to do on your calculator. So we're going to do that now. And I'm going to make sure everybody got that?
Yeah.
Yes or no?
Yep.
Yes.
Okay. That's 2 questions right there that will be on the test. All right. Now, everybody get out your handy dandy curve. And let's go ahead and mark that curve up. We know that within 2 standard deviations, we know that that's normal. Within 2 standard deviations, That always irritates me when I can't get that color right. And then we know that outside 2 standard deviations is called what? Unusual. We also need to remember the empirical rule, which means you add up all these percentages wherever you're going. Let's go ahead and add this. This arrowhead down here. Somebody tell me what this arrowhead right here is called. And what is this arrowhead right here called? What's this arrowhead called? Negative what?
-1.
No, negative infinity. What is this arrowhead called?
Positive infinity.
Positive infinity. But we cannot calculate with infinity. So from here on out in chapter 7, this arrowhead is not called negative infinity. It's called negative 9999. And somebody tell me what this arrowhead's called in chapter 7.
Positive 999.
9999. In other words, put a BAE number in your calculator for infinity. And the book and most statisticians will put either 3 or 4 or 5 nines. And that's as far as you need to go, 3 or 4 or 5 nines. I mean, you could put 8,888 if you wanted to, but that's not the maximum. 9999 is higher than 8888. So, but you could use 3 nines. You could use 2,426 if you wanted to, because this is so close to the x-axis. It doesn't really matter as long as you just have a big number here. Okay, so I'm going to put 3 things on. I only got 4 minutes, so I'm going to just show you how to do 1 or 2 of these. I want to find the area greater than 1.2. Okay, where is 1.2? Well, in 7.1, 0, 1, 2, 3, -1, -2, -3. Okay, here is, I'm going to take my blue marker and I'm going to highlight area is equal to greater than 1.2. And I'm going to take my blue marker and I'm going to make here is 1.2. And which side is greater than on the number line? To the right or to the left?
To the right.
So I want to find this area. Now, you can take your 0.15, 2 point, I'm going to put 0.15 here. I need somebody to add these up. 2.35, and this looks like probably 1.22468. So I'm going to say that's divided by 4, maybe, divided by 5. So 13 divided by 5 is 2, and then I'm thinking out loud. Just hold on a minute. 13 divided by 5 is 2.7. So 2.7 times 3 is 8.1, something like that. I'm going to say 8%. Okay, so that's 10.35 or 10, that's 2.5. I'm going to say about 10.5% by the empirical rule. So by the empirical rule, I'm going to do an estimate of 10.5% or 2.1050. Now, I'm not going to explain the empirical rule to you. Y'all should know what I did there. I just added up and I put a line here and I just estimated what that blue area was. And that is, I came up with 8%. You may come up with 9%. You may come up with 7%. but that's what I did. I added them up. Now I'm going to use, and I'm a little bit over. I've got 1 minute, so I'm going to go ahead and use, since this is a range. Which way do we read?
Left to right.
So I'm going to go from 1.2 to 9999 because that's what I want to find. So I'm going to do normal, second, vars, normal, CDF, and then I'm going to type in 1.2 to 9999. So here we go. Clear and clear. Second, vars, normal, CDF, from 1.2 to 9999. And enter. And that's what it looks like, and hit enter. I got 0.1151. So the answer is 0.1151 or 11.5%. What did I say with the empirical rule? I said 10.5%, and that's a good estimate that way. Now, why do you do an estimate? Somebody tell me, why do you do an estimate with the empirical rule?
You can't say exact, right?
Well, why do you do it? If it's not exact, why do you do it?
To give you like a rough estimate where it should be.
Exactly, to kind of check your work, to kind of like make sure you're in the right place. So when you do the empirical rule, when you come up with 10.5% and your answer is 11.5, you can pretty much do a thumbs up and say, I'm in the right area. And that's what we're going to be doing in 7.2. And we're going to add on to this Monday. Okay? Now, what do you need to be doing for homework this weekend? This is what I want you to do. I want you to read 7.1 and 7.2. If you get a chance, I want you to watch the other videos of 7.1 and 7.2 from the other two classes. I want you to do that priority. Okay? Then I want you to work on 7.1/7.2. And when you start doing problems you have no idea, then don't just stop. Then, if you've done that, I want you to go back and work on 6.1 and 6.2 homework. Why? Because you need to start getting this in your brain housing group. The 7 and 7.2, you need to start getting that in the brain housing group. So this is first, this is second, and this is third. All right. Y'all have a good weekend, and I will see y'all Monday. Bright-eyed and bushy-tailed.
Did you ever figure out how to do it on Excel?
Huh?
Did you figure out how to